Hello, everyone. Welcome to the session. Today, we are going to talk about a lot of additional things, a lot of important things pertaining to data structures. But even before we proceed further, let me tell you that, as I've rightly promised, we have provided all the additional details on the mind map. Let me show you those. On the mind map, we have given some additional details on the various features. Okay. Then we've also looked at, what are the variables in Python. Then we understood the type of operators. We'll be adding more details to arithmetic, relational, assignment operators. Okay. What does each and every, operation do? Logical operators, identity operators, membership operators, bitwise operators. We have also discussed in detail about the various data types. And we are going to add more information to each and every bit of it to help you all understand what each one of these actually mean. A lot of additional information would be pumped into each and everything. Okay, so unlike what was available earlier, we have actually tried to give as much information as possible so that this serves as a good, reckoner for you all. It should be able to help you do a quick recap of all the concepts that we have discussed about. It should also be able to position yourself in terms of clearing your interviews, in terms of working on various projects, and it should also help you on various other things pertaining to your BTech assignments or internals. A lot of questions would be certainly picked up from the topics that we have already covered. Okay. Then we have libraries, we have various functions. We spoke about inbuilt functions, custom built functions, that is user-defined functions. What do you mean by arguments? We have discussed that. We have looked at how do we actually handle errors? How do we effectively capture the various errors? Then we discussed about loops, in which we spoke about, finite loops such as for loop, then infinite loops, which are while loops. What do you mean by break? What do you mean by pass? What are the various conditional statements such as if statement, if else, if, so on and so forth. We shall take this discussion further and we shall talk about Pandas, which is very important from data structures standpoint. Pandas is all about dealing with your data, right? And within data structures, you have arrays or vector. We have 2D arrays. We have matrix. We have spoken about that. And today we are supposed to get started with one of the most important libraries called as Pandas. Pandas is one such library which is used to deal with data frames, which is used to basically manipulate the data. Now, what do we mean by manipulate data? The moment people hear about manipulation, people assume that it is something bad. No. Manipulation means probably you want to bring in 3 more columns from a different data set and append them to your existing data set. That could be one reason why you want to manipulate the data. Maybe you want to change the names of the columns. That is also manipulation. So manipulation does not mean wrong. You'll have to remember that. Okay? So we have data manipulation. That's all about dealing with data, deleting certain columns, adding columns from a different data set. deleting certain rows, changing the names of the columns. All these are part of data manipulation techniques. And NumPy is used for performing numerical calculations. It is used to perform numerical calculations. Next. So all you need to do is just click on the run to be able to import this. Then when you say dir of PD, it's a directory that we are going to open. Then today, by the way, I'm also going to explain you about another IDE, Integrated Development Environment, which is Spider. We already have seen Jupyter. This is Google Colab, and Spider is something that we will explore, or we will at least execute a few lines of code in that. Post that, we will also, in the remaining 2 sessions, we have 2 more sessions. We shall certainly look at Studio Lab from Amazon, okay, so that you get exposure to all of these IDs. You can mention about all these things on your resume. Okay, so once again, you need not again import friends. That's not needed. But if you restart your kernel by any chance, or if you refresh this page, if you connect to a different server on Google Colab, etc., then you'll have to import the libraries once again. Just remember. So when you say directory dir of PD, you will see a lot of additional information which will be available in this. And you can make use of a lot of functions which are available. Like there's something called as creating dummy variables. You can look at that. There is something called as reading your CSV file, reading your Excel file, reading an HTML file. You can read a pickle file, JSON file. You name it, friends, it's available. You can read a table in a text format. You can read XML file. You can directly connect to SQL database, and you can query the data from that. SQL tables. SPSS is yet another data science software from IBM. You have SAS product. You can connect and you can read the SAS files directly. All these are a bunch of benefits, friends, that exist. So we'll move on. We possibly cannot look at each and every function which is inbuilt and available within Pandas, but we'll try to cover as many as possible. Once again, you need not import, but yep, I'm habituated to maintaining code modularity, and hence I'm writing this, okay, because I'm explaining. But in real world, when you work on projects, you don't often try to, import the libraries. If it's imported, once for all done, right? You will not time and again keep importing that. Anyways, then we are creating a variable or an object called x1, and we are creating a list. Remember, list has square brackets. We discussed in the very initial sessions that list will have square brackets. And then we have 5 elements, 1, 2, 3, 4, 5. You are taking these 5 elements, assigning it to an object called x1. Then you have 10, 11, 12, 13, 14, all these, and then you're assigning it to another variable called x2. Then we are printing out range of 5 numbers. We are creating or converting that into a list and assigning it to another variable called x3. Then you take these 3 columns, x1, x2, x3. Okay. And then you're creating a data frame and assigning it to x. And when you say x, you get to see the values. Let me run that. And you'll see that 3 empty, columns got created. It's just a frame with the column name. We did not add anything to those. Right? When you say columns, you create a data frame using explicit lists. Okay, let me also read once. If there are any mistakes, I'm gonna remove those grammatical mistakes. Okay. All right, this is done. And then we are saying take x1, assign the values. So what we are doing is converting the list format into Pandas series format. Every column in a data frame or within Pandas data frame is called as a series. All the columns put together is called as a data frame, as in you have your photo frame. In that way, you create this, right? Instead of calling it as a photo frame, we call it as a data frame. And then you have list of items that we are creating. Or each column is called as a series, Pandas series. All right. And then we are taking all the elements of x2 and we are assigning it to a column called x2. You have 10, 11, 12, 13, 14, all those numbers are there. And when you say you want range of numbers, 5 numbers, it would print 0, 1, 2, 3, and 4. These are the 5 numbers that we have, and we are assigning it to x3. You're taking that x3 and assigning it to x of. So x of x3 will refer to this column. X of x2 will refer to this column. X of x1 will refer to this column. Within this x1, you're assigning the values of x1. Within this column called x2, you're assigning the values of x2. And within the column called x3, you're assigning the values of x3. There we go. And this is a typical data frame that we have. Then, if we try to copy the same data into another variable, what happens? Okay, shallow copy is one option wherein you say deep equal to false. This shares the data and index with original, variable. Original, I would say data frame rather, right? And when you say deep equal to true, deep copy has own copy of data and index. What does that mean? Let us understand by issuing certain operations. We'll do some operations and try to understand the explanation in a very detailed manner. So if I were to run this, what are we doing? We are copying this x. X has all these 3. You copied that. And when you say deep equal to false, okay, I maybe did not run this. Let me run this. Okay, we have this. Now let me run this. Now here, you're saying copy whatever is part of x. Whatever is part of x is these 3 columns. You copy that is what you're saying. And then store it in DFF. And when you say print DFF, okay, you get to see this table. Or typically data frame, right? And when you say x dot copy, you're saying go to x is this, copy that, but deep equal to true. What does this do? Let's see. And then you're assigning it to DFF1, and then you're saying print this. There we go. This is what we are doing. Now, here is the explanation. Since we have done this shallow copy, let's see what happens. You're saying go to DFF, which is this table, and then say x1 of 0. Refer to column x1, and 0 means you want index number 0. Okay, go to x1, index number 0. Replace the value with 10. So x1 of 0 is this, which is the first element here. You're replacing that with 10. So, and then if you say print, yes, you see the 10 over there. So one element got changed. Then, if you now see what is there in X, wow, X also got updated. While you update this DFF, which is nothing but a copy of X, your original data also got changed. So any change in copy, this is a copy that you had, right? You copied the content of X into DFF. Any change in this copy will make changes in the original data set also. When you say deep equal to false, this is how it reacts. Okay. If you have a deep copy, that means if you say deep equal to true, then what happens? When you say deep equal to true, and then when you say DFF1, it goes to DFF. Let me first run this. Let's first print DFF of 1. And then let us see first what is there in that. Yeah. So look at what has happened here. When you say DFF of 1, it shows you the data. Initially, what did we do? We have created X, which is nothing but this. We copied the contents of X into DFF. And we have also copied this into DFF1. Here we use an argument called as deep equal to false. And here we have used deep equal to true. And then what happened is when we made changes to DFF, the changes done in DFF also got reflected in X when we use deep equal to false, which is also called as a shallow copy. Shallow copy. This is also called as a deep copy. When you say deep equal to true of DFF1, and when you say DFF of X1 of 0, so that means DFF, go to DFF, which is this. We already printed DFF. Go to X1. And of 0 means within X1, go to row number 0. And you have a value. Assign 15 to that. There we go. Now, when you say print this DFF, it will show you the values of DFF with this getting updated. But when you say show me X, X doesn't change. It gives you the same value 10 here because, in the previous line of code, we updated that. That's the reason. Okay, but this 15 is not changed here. So whatever change you make to this copy of DFF1, which is called as a deep copy, would not make any changes to X, which is your original copy. So any change in the copy format will not make changes in original data. Okay, so for various reasons, if you want to maintain a duplicate of a specific data set, you might want to say deep equal to false. And if you want to make some changes and experiment whether your code is working well or not on a specific data set, then you might want to say deep equal to true, and then you might want to proceed further. All right, let's get into the next thing. Now we have, we are going to now convert the list format into Pandas series format. Right? When you say pd.series of x1, that x1 gets, if you want to assign it to x1 column, then all those numbers will get assigned. Whatever is part of x1 would get assigned to this. Okay, we can do one more thing. We can just say, first, let me print and see what elements are part of x1. Let me type that. Yeah, this 1, 2, 3, 4. And when you say, let me see what is the type of this x1. So go to run it. It says that, oh, why is it not showing me the type? Just give me a minute. Why is this not working? You'll have to just excuse me. Sounds appears to be a little strange. Okay. Let me do one thing. I can also use print rather, right? But let me not experiment while I'm live. Let me do this. Yeah, it's showing that this is a list. Okay. Now let me write a different piece of code. Since this is what happens, too much of analysis will make you get into paralysis. You know that was a second line, and second line, third line, whatever line, apart from the last line, if you want to see what is there in that or what is the type, you should have used print of this, right? Would have given you the, anyways. Now we want to convert this list into series. So what do? Pd.series of x1 using assignment operator. You assign it to the variable x. In that you have x1 column. In that you want to put this x1 content. Similarly, in x2 also you have some data, some values. Put it in x2. Similarly, in x3 also you have certain values. Put that in x3. Okay, and then see what is there in your x. Yes, you have this. Now, if you say, show me the type of x. Let me print the values of x once again, and let me look at the type. Now that there's the last line, it says that this is a data frame. Just remember that every column, okay, would be called as a series within Pandas, and collection of all the columns would be called as a data frame. Yes, bear that in mind. All right. There are multiple ways of accessing a specific column in a dataset. One way to refer to a specific column is by using dot. You're saying go to X. All right, I'll go to X, which has all these columns. Which column do you want to refer? Say you want to refer to X1. You say dot X1. That would refer to the first column. Name is X1, data type is integer. Then if you say go to X and refer to this column X1, double quotes, that will also refer to this column. Okay, and you're saying it is a integer type. And if you want to access multiple columns, accessing multiple columns, giving column names as input in list format. So you can do that by giving the column names as input in the list format. In list, within the square brackets, you mention all the elements. Here also we are doing the same thing. Okay, we are trying to refer to the various columns and X of those values. We can also run that and see, what values we get. We have X and X2, right? We are trying to access multiple columns at one go. Then we have something called as accessing the elements using index location. That means you try to access each cell by row and column. When you say X dot columns, you get to know what are the various columns. Out of those columns, if you say index location of 0,3 and this, okay, and then X, it will show you only those relevant columns. Okay, now let me do this. Since we are not using the print function, you're not able to see the columns. Okay, when we say print of X dot columns, X has X1, X2, X3. Data type is object. Actually, it shouldn't be like that. These are integers, but anyways, that aside, we do type casting, that is converting one type to another. We'll get to that later. Then when you say go to X dot index location, within the square brackets, you have rows and columns. When it comes to rows, we are saying we want rows from 0 until 3, means 0, 1, and 2. You have 0, 1, and 2. And then you're saying you want only the first column. Okay, always it is rows and columns. Okay, so you're saying you want the first 3 rows and 1 column. Okay, and then if I were to print this, it would show you those specific columns. So if you look at it, when you say X will refer to this entire data. But when we say print x.index location, it's giving you first 3 rows and this column. First 3 rows of the column. Of which column? Column number 1. So this is column number 0 and 1 and 2, right? So it will refer to 0, 1, and 2, which are the first 3 rows of column number 1, which is this. Now, if I say go to X, go to index location 1, colon 2, comma 1, colon 2. Let us see what it does. That means you're saying you want, it will not give you the entire data frame. Okay, anyways, that's a wrong explanation. It will give you column 1. And here you want 1, colon 2 means, sorry, my bad, sorry. This will give you row details and this will give you column details. Sorry, my bad. To give you row details and column details. You're saying give me row 1 and column 1. 1, colon 2 will give you only 1 because the last value is ignored. This will also give you 1 because the last value, index value, is ignored. So let me run it and also correct the line of comment. Refers to first row and first column. And then here, you have something called as location. There are 2 things, friends. One is called as index location. Another thing is called as location. What is the difference between these 2? Let us understand. If you say 0, colon 2, you would be referring to rows. Whenever you have square brackets, just remember that it is nothing but rows, comma, columns. Within rows, 0, colon 2 means row number 0 and 1. And within columns, you have x1 and x2. Let me run this and show you what happens. So it is referring to 0, 1, and 2. And when it comes to columns, it's going for x1 and x2. Zero, 1, and 2. But whereas when we have done index location, it was referring to the last value was being ignored. Here also the last value ideally should have ignored. But since you are using location, it's considering that. Now, if I say column name instead of column names, if I were to say 0, colon 2, for instance, it would throw an error because it doesn't understand these. Okay, you should certainly say what is it that you're trying to refer to. Which column? You have to specifically mention the column name over there. Okay. If you do not mention the column name over there, it will start throwing errors. Okay. And if you want to have the names of the columns in that way, then you also have to mention that as a list. Only then you will see X1. When you say 0:1, it will refer to both the rows. So that's the difference, friends, between index location and location. Mention specified columns. Mention specified column names. Okay. And if I say comma X2 now, let's see what it does. For both X1 and X2, it is giving the values rows 0 and 1. Okay. Now let us create a data frame using Pandas data frame. I'm going to create one column with these values. Then I'm creating two data frames just to help you understand on how it works. Okay. Let me run it first. Once we run it, we also want to see what will be the values within this df1 and what will be the values within df2. And then we'll merge it. Okay. First, let's run it. Okay. So what we have done here is print of df1, in which you have 1, 2, 3. Okay, and you're creating a column called x1, which has 1, 2, 3. You're creating a column called x2, which has 4, 8, 12. Like a dictionary, we created that. And then we printed the results. Then we have df2, where you're having again a data frame with x1 and x3. x1 is 1, 2, 3, 4. x3 is 4, 8, 12, 15. And then when you say print, it will print the results. Then pandas.merge. When you try to merge both the data frames on X1, because when you want to merge, at least one column should be common. Only then it will be able to merge. Even if the columns are not same, it will merge. We'll do both. We'll do both. When you say merge, df1, df2, we'll try out all the options. On equal to x1, when you do that, if you look at x1, it looks at the match 1, 1, 2, 2, 3, and 3. So only those first 3 are copied here, and you are able to see the results. So you have x1, you have x2, and now x3 also got created. Now, if I don't use this, what happens? By default, what does it do? Okay, it's doing the exact same thing, because when it tries to map, it will look at the columns. It will understand that x1 is common column. It will look at the match, and then it will pick only those. Now let's do one more thing. Let me create x3 and x4. Now let us merge these two. It shows an error. It says, hey, I'm unable to see the exact match. Even if the column values are the same, it starts throwing that error. Okay. And if you have one column less, one element less in one column, and if you have another column with more number of elements, still it throws an error. Okay. So in order to merge, just remember that at least one column should be common. Okay, only then can you merge. Here, the number of elements Sorry, should be the same in both. Here, if you're going to have 4, here also you need to have 4, but it doesn't really matter. Okay, I'm just changing the numbers for the sake of it. So we have x1, df1, and if you print, you get df1. You have df2. When you print, you get df2. Okay. Then when you say merge, and if you want to see the results, you get to see this. Wherein you have x1, you have x2, and then you also have x4. Okay, it got merged because x1 and x1 are the same. Then we have joining operation. How does this work? Let's see. So you are creating x1, one column, x1, and we are creating another column, x2. Then we have an index, 2000, 2001, 2002. Then you are creating another data frame, x3 and x4, and you have values in this. Now, when you say print df1, df1 gets printed. When you and print star star, all these stars, and then when you say print df2, df2 gets printed, and then star star. Then when you say df2 dot join with df1, not merge, we are using join. What happens now? Let's see. So we got this df1 created, and when you print out the results, you get this. Then you have df2 created, another data frame. Of course, this print statement will give you stars, and then this would give you df2. Then you're having stars. And then you're saying df2.join. When you say join, it does not need the same column names. Point number 1. In merge, we need the same column name, otherwise it will throw error. In merge, that's not the case. Okay. So you're saying df2. So first take df2. df2 is this. And this is df1. Take df2. df2 contains x3 and x4, and you have those columns. Then join df1. So you're saying, I have this also. Let me join that. Okay. But when it joins, right, it is actually joining based on your index numbers. You have 2000, 2001, and 2002. Wherever you have, say here you have 2001, but 2001 value is this 1 and 4. You take those 1, 4. Okay. And for 2001, you have 2 and 8 here. So you join those. Then take index number. First, it's df2. This is df2. Let me write it. df2. And this is df1. So it goes to df2 first because you're using df2. It goes to this index number 1, 4. And then it will go to df1. It will look for that index number, and you have 2 and 8. It adds those two. Next, it will go to the next row, which is 2002 index number. It takes for 2002, 2 and 8. And then here also it will go to 2002 and 3 and 12. It prints those. Then it goes to 2003, 3 and 12. But here, since you do not have 2003, it will say not a number, not a number, like missing value or null value. It's just saying that it's not a number. Okay. And what will happen now? Again, of course, we have to look at what will happen if I don't have this index. What will happen if I don't have this image? Will it still run? Will it still join? Will it throw me errors? Let's see. Okay. Now all it is doing is it's taking 1, 2, 3, 4, 8, 12. 1, 2, 3, 4, 8, 12. So it's taking first df2 because you want df2, and df2 contains these values. It will take 1, 4, 2, 8, 3, 12. And then you're saying join with df1. And when it comes to df1, you have 1, 4, 2, 8, 3, 12. You take those values, print, close it. If I have different elements, then what does it do? Then will the join actually happen? Yes. When we have tried to merge it through an error, but here what happens is it will go to df2, it will take all the values, and then it will try to join this, join the values of df2. Column x1 and x2 are taken, and it will try joining. Since this row 3 doesn't exist here, it will say not a number. So join gives you some more flexibility, but merge the column names in both the data frames. At least one column should be same. Point number 1. And point number 2, in merge, you need to have equal number of elements. Okay, yeah, unequal number of elements also. Sorry, my bad. But then, yeah, in merge, that's one thing, right? At least one column should be same. Whereas in join, even if you do not have a common column, it will join. Okay. And here in merge, since you have 4 in df2, 4 rows, it's not showing the 4th row, and then it's not saying that NA values would be there, right? It's merging only by taking the data frame which has the least number of elements. If the data frame 1 has 3 rows, it is only taking 3 rows and then doing this merge. Whereas here, it is taking the highest number. In df2, you have highest number, right? But then, what would happen if I say df1 dot join of df2? Now, does it behave in a similar fashion? Or what happens? So if you look at this, if you go to df1, and df1 contains only 3 rows. So it will take those 3 rows. And then it will join with df2 by taking only the top 3 rows, 1, 2, and 3. The last one is ignored. Since you're doing it the other way around, df1, first you're taking this, and then you're joining df2. So whichever data frame comes first, that is given precedence, that is given importance. If it has only 3 rows, df1, when you join it with df2, then you take only 3 rows. Now you're creating a data frame. Here you have x1 and x2, 1, 2, 3, 4, 8. And then you're saying print. Star is just to segregate. Ideally, this should have been there. Right? But anyways. Now, assigning index names using column names. So what you're doing is df dot set index using x1 in place equal to 2. For this in place, I am going to spend some time and explaining further. Right? Just for now, bear with me. Right? When you say df, it's saying that set the index using x1 in place equal to 2 means in the place of these index values, put x1 values. X1 has 1, 2, and 3. 1, 2, and 3. And then you have x2, which obviously has 4, 8, 12. This is how you can use a specific column and the values of that column and ensure that they become your index numbers. What if this is 4? 1, 2, 4. And what if I run this? And what if we see the values here? What happens? See, it has taken 1, 2, and 4, and it has put 1, 2, and 4. So it's not necessary that numbers should be in a sequence. Even if the numbers are not in a sequence, you get to see the results. Okay, next. We can also change the column names. Let's see how to change the column names. So you are creating a data frame. Okay. And we are just renaming the column. Let me print the results and then show you. Okay. And even if you don't have that comma, it should work. So let me rather remove that. Okay, now you're printing this DF. And DF contains how many rows? 3 rows, 0, 1, and 2. X1 and X2 are the 2 columns. Within X1, you see 1, 2, and 3. 1, 2, 3. Within X2, you have 4, 8, 12. And then you have all these stars which just segregate this. And then you're saying rename the column X1 with X3. Column from and this column 2. Meaning from X1, you want to rename it to X3. So this X1 became X3. And then you say print of DF, which gives you the values. Okay. Then you are creating a data frame with 3 columns. Column 1 is going to have numbers 1, 2, 3. Column X2 will have numbers 4, 8, and 12, and then indexes 2000, 2001, and 2002. Then you're creating another data frame where we are creating X1 with 4, 5, 6, X2, sorry, X3 with the values 14, 16, and 18. And then you are having an index, okay, wherein you are having values 2003, 2004, and 2005. Then you're trying to concatenate. Concatenation. Okay, fine. I had that spelling mistake. This is fine. Now let's see what happened. When you say join, it is going to join based on columns. Now, when you say concatenate, what happens is, let me first here print out the results of DF1. Let me also print the results of DF2. And then let me show you. Come on. Yep. So we have DF1. When you try to print out the results, it's going to show here. DF1, you're creating 2 columns, 1, 2, and 3 in X1, and in X2 you have 4, 8, and 12. And then you have index values 2000, 2001, and 2002. Then we also have another data frame where we have X1 and X3. X1 contains 4, 5, and 6. X3 contains 14, 16, and 18. And then you have your index values. You are trying to print the results. Then when you say concatenate DF2 and DF3, first it will take DF2. Then you have DF1. So in DF2, you have 2003, 2004, 2005. But when you concatenate with DF1, you have 2000, 2001, and 2002. So let's take DF2. And in both of these, here you have X1 and X3. Here you have x1 and x2. So let's see. It will take x1 and x3 and print out these results. 2003, 414, 2003, 414, 2004, 5, 16, and 2005, 6, and 18. And then when you say concatenate with df1, you go to df1, it will take 2000, 2001, all these. But it will take x1 as is, x3 is not there. So it will say NaN, but x2 is there. So it's a new column. It will add that. And it will say for df2, you don't have x2. So all the values are Na, not a number, NaN. And then this 4, 8, and 12 would appear. Okay. This is how concatenate option works. For merge, you need a single column, which is common in both the data frames. For join, you don't need that. And for concatenate, if you have different columns, and even if you have different index numbers, everything will appear. In join, it was combining the common index numbers. Okay, if you observe here in join. Okay, so only the common index values were taken and it was joining them. Even if you have different columns, fine. Whereas when it comes to concatenate, whether you have same column names or different column names, same index values or different index values, doesn't matter. Okay, that's how it's going to print. You can also try this. What if I say comma 8 and then comma 20, and then if I let the index numbers remain only 3, would it throw an error? Certainly it would. Right? If I say comma 2006, would it merge? Yep. Right? Without any issue, it has to merge. That's how it works. Once again, I want to show you this directory of PD, just to say that these are the various functions which are available. We can experiment only a few, but I would like you all to explore all the other functions which are available. It's pretty simple. In the next version of it, we aim to train you all and teach you about all the functions which exist so that it becomes very clear on what each function does. So we are importing pandas. Here is a data set. You are creating a column called cars and you are assigning the values BMW, Volvo, Ford. And another thing is passing some variable and then 3, 7, and 2. Then you're saying, take this data set, which is nothing but a dictionary with key value pairs, and convert that into a data frame. There we go. So you have a data frame, you put in that, and when you print out the results, it shows like this. Okay. So this is a data set. My data set is actually, let me print out the results here. It's a dictionary. Print my data set. Let me run it. Okay, so this is a dictionary. This is a key. These are values. Passings is a key, and these are the values. So you have a key value pair. You can also, print the type of the data set and see what is the type. Just in case it says that this is a class dictionary. And then you're converting that into a data frame. Next. Okay, what I want to do is quickly open, Spider. All you need to do is open Anaconda. You just go there, search Anaconda, click on the Anaconda navigator, and this is what appears to me. I don't know why this is slightly distorted, but that's fine. When you click on launch here for Spider, it would open Spider for you in this way. Let me close every other file because I just want to have one single file and show you a few options here on how it appears. Okay. This is how the screen appears, friends. Now, this look and feel that you're seeing, wherein you have 4 windows. Okay, you have 4 windows here. This is window 1, this is window 2, this is window 3, and then you have window 4. Right? You have 4 windows, friends. 1, 2, 3, and 4. Okay, you have 4 windows. And if you want this kind of a view, then you need to go to View, go to Windows Layouts, and click on R Studio Layout. If you don't like this layout for any reason, for any strange reason, click on Spider Default Layout. This is how the layout appears. You write your functions here, say 1 plus 1. And to execute this, you need to run this. You need to click on this. What happened in our, in Google Colab, we started clicking on this run. Okay, in Jupyter also, there was a specific line where you could run. Here also, you place your mouse cursor anywhere on that line, doesn't matter. You just click on that and it will get executed and you will be able to see the results here on the console. This 98 is 98 lines of code. Right? And if I want to clear the console, I just need to say Control and L on my keyboard or Command and L if you're using MacBook, and then it would clear the console. In this way, you can start writing the code. When I say 8 multiplied by 3, and when I click on run, it would show the result as 24. Before that, I've executed 100 lines of code. That's what it says. Okay, that 100 number says that. Tell me what is line number 101. Here also you can type, friends. 7 multiplied by 2. Directly also you can type, but that's not the good practice. If you can type your code here, you can at a later point of time go to File, click on Save As, right? And save your file name, class practice. And then it will save, let me save it in the downloads folder. See, it is going to save this file in .py format. You can also go here and save your data set. Okay, or you can download it using .py or .ipython notebook. There are a lot of advantages when you use Spider because when we load a specific data set, you can directly see the data set. Okay, you have something called as Variable Explorer. You can directly see your data set there. There's one more beauty. You just need to click on this option there. And then it would open a pop-up. Go look out for the file you want to access. So you want to access education and then select that file, jot down. It could open this. Okay. So I will change this to education. Click on next. You can give any name, variable name, you know that. We can give any name, sorry. And then you select data frame and click on done. And you'd see the data frame, right? It has 773 rows and 3 columns. Just by double clicking on that, I can open and start exploring the data frame. These are the benefits that we have in Spider. I will talk more about that when we connect tomorrow. And before I wind up, please, I request you all to do these things. Subscribe to our YouTube channel. Not just that, please inform to your friends, relatives who might benefit, share the videos. Okay, we'll be doing many free stuff, as in how the days progress. You all are going to certainly reap a lot of benefits. Number two, we are posting questions on LinkedIn. So please answer those questions. You just go to 360 Digit MG LinkedIn page and you would find the data over there. Okay, and you can take it to the next level. And please follow us on LinkedIn as well, because we'll be posting a lot of interesting stuff out there. Thank you all so much for your patience and listening to me with patience. And I'm certain that when we do the next round of Python programming, it will have more information. I can guarantee you guys that, right? Thank you so much, and have a great day or good night.